Any doubts from yesterday's class? And yeah, I'm audible or not?
Yes, sir. Audible.
Actually, I have taken almost all the topics like molecular breeding, the mock tests, and rest will I will take after covering some topics. And those who are attending a record, those who are going to listen the recorded classes, I'm requesting everyone to attend the live class, engage in the discussion, ask questions, and answer the question I'm going to raise in the classes. Okay, because of limited number of students, what are the topics I want to cover? I'm just covering and I'm closing the classes. The more numbers, more doubts, more will be the discussion and more will be the engagement, then more you're going to learn. Okay, rather than just attending 5 to 10 questions of about some topics. In many books are there, objective books, B.D. Singh and B.K. Prasad. Out of that book, nobody will going to take the question out of that book. Actually, objective book of plant breeding and genetics by B.K. Singh and like B.D. Singh and B.K. Prasad. It's like a Bible. Even though we prepare question paper and we look that book, we're going to look about that book only for preparing the questions. That's why I try to be more engaging in the class. Try to be more engaged in class. At least to make your time to discuss. Okay, it's not like that. I have given money, I had to do everything. It's not like that. The attitude towards learning is to be very passionate. Okay. Yeah. Okay, we will start today's class. Today we have discussing about the different types of heterosis, what is the genetic concept behind heterosis, and what are the different objections for the different hypotheses, and we have discussed what are the steps in the hybrid breeding. Like to develop an hybrid, what are the steps we need to do? Evaluation of inbreds, choosing the parents, evaluation of inbred, and making the crosses, choosing the crosses. Overall, in nutshell, we have discussed in a summary way. Like in today class is more like I will discuss in more detail about the hybrids, the different types of hybrids, and how to develop different types of hybrid, what is the history of hybrid car, and the whole class I'm taking maize as a case study. Okay, and we most of the things we're going to discuss regarding the maize because the maize is a classical hybrid plant where hybrid technology was developed. We're going to discuss about that. And I have not discussing what are the different types of heterosis like heterobeltosis and commercial heterosis, standard heterosis. Those things are can read. Okay, it is just definitions. Okay, if the F1 is bettering over the one of the parent, it's called as heterobeltosis. If the F1 is superior over the commercial check, it exactly the commercial heterosis. Okay, there are simple definitions. You just read it. And today we are going to discuss about what are the different hybrids and what are the history of hybrid corn, how this concept has emerged, what is inbred, what is the importance of inbred in the hybrid breeding, and how to evaluate inbreds. We will going to discuss. Based on the how many number of parents you are going to cross, the hybrid can be classified as two-parent hybrids and multi-parent hybrids. And based on the type of parent you have used, there are two classifications: conventional hybrids and non-conventional hybrids. Means if you are using inbred as a parent, both the parents are inbreds. Then it is if you're developing in a hybrid F1, means this is conventional. If any one of the parent or the both the parents, they are non-inbred. Means that the non-conventional hybrids. Means at least one parent is a non-inbred. What is an inbred? It is inbred.
Homozygous, complete homozygous cross-pollinated crop.
Inbreds are nearly homozygous. In cross-pollinated crops developed by continuous selfing. Okay. Why we need inbred in hybrid development?
Sir, so
Sir,
that
if
we
we
can maintain inbred each and every time for crossing, sir, each and every year. If it is fixed,
That is one thing.
so
Why we need to across? Why we need if there is some percent of heterozygosity, it is desirable or not? Like in inbred residual
no,
heterozygosity
sir. No, sir.
undesirables.
should be completely homozygous. But inbred is always nearly homozygous. To develop a complete homozygosity, what techniques are there?
Uh, uh,
Doubled haploid.
submitting, submitting.
Doubled haploid technology.
So,
That
yes,
is
sir,
the
double
only
apply.
technology where we can develop a complete 100% homozygous inbred lines. And that will be discussed in separate class, double haploid technology and the role of double haploid technology in hybrid breeding. Okay. We'll cross an inbred and we'll develop an F1. And that is called as conventional. If there is a residual heterozygosity will be there in this one, there will be a lot of segregation and you may not expect that much high performance in the F1. That is one of the. That's why if you have to use a completely homozygous inbred lines, minimum residual heterozygosity, so that your performance will be very high in the F1. Then, when you look into the detail about conventional hybrids, like just I'm brushing up the basic things. It may be easy for you anybody. Just single cross hybrids. You just cross two inbreds. Three-way cross hybrids. Okay. A hybrid is crossed with another hybrid. Four-way cross hybrid. A two first involving a four inbred and you're making a cross between two hybrids. Like modified single cross hybrid. Means many times what will happen? Your F1, they're not that much good. See, like sorry, your inbred, they're not that much well performing. Many times it's not going to well perform because they are homozygous in condition. They're poor performers many times. You may get a less number of seeds, or many reasons you may not get a good number of seeds. Seed setting is very low. In that case, we are using an improved version of an inbred line. It is called a sister line. So that you first cross your inbred with another inbred, like called sister line, which are related in nature, and we are increasing the seed set and taking this seed and crossing with another inbred B. Okay, that's the why we are going for modified single cross. If your inbred is not that much good and seed setting is very low, in that case, first you cross that inbred with the sister line, increase the seed production, then or improve the inbred, then you cross with the another inbred. That's the modified single cross hybrid. And it's double modified cross, same the way. Okay, in both the inbreds are poor performing, then both the inbreds are crossed with sister lines, then we are crossing, then we are getting a double cross hybrids. Then modified three-way cross in the same way. Okay, this is about a different conventional. We will discuss in detail. What is the advantage of? What is the main advantage of these things? We are going to discuss in next slide. But one of the limitations were availability of the good vigorous inbred lines is very difficult. In many crops, we may not get a better performing inbred lines because their high homozygosity in nature, there is maximum expression of recessive alleles or maximum expression of deleterious alleles. Okay, then the performance will be low, and there will be high extensive inbreeding depression in the cross-pollinated crops, and inbreds are developed by continuous selfing. Then definitely the performance is poor, and if the performance is poor, you may get a very limited pollen or very limited anther, so that you may not take the cross sufficiently. That's why the availability of a good vigorous inbred lines is very limited in the case of hybrid breeding. Then poor yield of seed parent. Your female, in female we getting the seed set, but if female is very poor, then it may not going to get a uh, good number of seeds. If very seeds are limited, then you can't release the varieties. That's the one of the biggest problem in hybrid breeding. Maintaining inbred parent itself is a very difficult task, and having a good inbred line so that having maximum seed set is another limitation in the hybrid breeding. And shy pollen shedding in the pollen parent. If you take a male inbred, if it is a poor performing, then definitely it produces a very less pollen. Then if you have a very limited number of pollen, it's very difficult to make crosses with the female parent. Okay, that's why having a good inbred line with a maximum pollen and maximum like a seed setting capacity, that is more desirable, but it's limited. And lack of nicking. For example, we will discuss what is nicking. Anybody have an idea what is nicking?
Synchrony in flowering of female and male parent.
Yeah. Where you have read these things?
Your class only, sir.
I think I thought you were reading the book called, can you guess what the book? Read the book by Principles of Plant Breeding. Like, I'm forgetting his name. Okay, one author, English author book is there. I uploaded that book in the website. Please read.
George Jacob.
Yeah. Already forgetting that name, author name. George Aquach. Okay, read that book. It's very important. Then, for example, you're crossing inbred A and inbred B. It's like a double cross. How you can develop a double cross? Okay, but nicking means you're crossing male and female. They should flower at same time. Means your seed set will happen. If it is flowering after 50 days, it is flowering after 75 days. When the pollen is ready, stigma is not receptive. When stigma is ready, the pollen is not viable. Then seed set will happen or not?
No, sir.
Yeah, that's what a syncing is. Means nicking means synchronous flowering between the two inbred parents. Okay. There is another term called as anther silking interval. Means that is time interval between the male and female flowering. Okay. Anther sinking interval. We'll discuss in detail. Okay. Then when you come to non-conventional hybrids, they're intervarietal, top cross, and double top cross. Means you're crossing a two open pollinated varieties. It is called as intervarietal. You can make cross a variety into inbred, it becomes a top cross. And many times in the exam, it asks what is top cross, what is double top cross. Many times we are going to confuse between them. If they ask double top cross, one of the parent is hybrid and another parent is variety. But if they ask top cross only, one of the parent is a variety and inbred. It may look similar, but there is a huge difference. Okay, crossing a variety with an inbred having a different consequences, and the crossing and a hybrid with a variety having a different consequences. Okay, please remember this difference. Okay, then what is the disadvantages of a non-conventional hybrids? They are low performing because, as I told, they have segregating. Their varieties are means they have high residual heterozygosity. So many genes are segregating, and you may not get a good performance as like when you cross two homozygous parents. Okay, that's what one of the reason why the non-conventional hybrids are not very famous. Okay, ruling are single cross hybrids. Other than all are not performing well. We'll discuss what is the advantage of single cross hybrid. Then lack of uniformity. Because of high residual heterozygosity, in F1 you may get non-uniformity because of still the genes are segregating. They may not exactly heterozygous here. They may homozygous. Some genes may homozygous. Some gene may this one. Like this. That's why always there will be a lack of uniformity in the non-conventional hybrids. Then seed standard and certification. If there is a lack of uniformity, we may face difficulty in standardizing some protocols like the distance, isolation distance. You may not get meet the isolation distance. Okay, there are several C standards and the field standards. We are not able to meet the standards if we are using a highly heterozygous population as a parents. That is one of the disadvantage of the non-conventional hybrids. And maintenance of non-hybrid parents, because we need to maintain the varieties in open pollinated condition. Okay. And the maintaining the nature, maintaining the intact nature of that particular variety will be very difficult. Because of continuous open pollination, they may get desired performance or desired character in that. Maintenance of the desired character itself is difficult when you're using a parent as an open pollinated, like open pollinated varieties or any other non-inbred parent, non-inbred lines are as the parents. That's what the disadvantages of the non-conventional hybrids. One is low performance, lack of uniformity, and it's unable to meet a seed standards and field standards, and where it will face the problem of certification and maintenance of non-inbred parents. Like it's very difficult to maintain because you have to maintain the open pollination condition, and the exact nature of the desired nature may not maintain. Then there is two important terminologies when you are reading with a hybrid breeding. You are going to for any company, it is very difficult. Maintaining the inbreds which having a same nicking, and maintaining the anther syncing intervals is very important. Getting a successful hybrid. Okay, those who are working on mating designs or those who are working on some diallele designs, are they are knowing about this. What is the importance of this? Anther syncing interval means the time difference between the pollen shedding and silk emergence. The difference, okay? For example, it matures at 75 days, it matures at 50 days. Like it flowers at 50 days, and another parent, it flowers at 75 days. This interval of 25 days, it is called as anther syncing interval. This anther syncing interval factor can be minimized by many ways. Either you apply some growth hormones, accelerate the flowering, early flowering into late flowering, or late flowering into low flowering. Means you modify some flowering dates by staggered sowing, or by application of some growth hormones, or by applications of some fertilizers, or drought also. If you give irrigation to the particular inbred parent, so that will flowers late. Or in some crops, for example, you take mung bean as I'm working. If you give drought conditions, the flowering will come very fast. Means at 30 days only it flowers. If you give continuous in Kharif season, it may flowers at after 35 days, 40 days. Means you can manipulate the flowering dates, and you can reduce this difference by using any agronomic methods, chemical methods, biochemical methods, target sowing. There are a number of ways or manage, a number of ways are there to manage the difference. Okay, to manage or modify the anther syncing interval. Then another terminology is called as nicking. Nicking means the synchrony of flowering of male and female. Means if you are managing anther syncing interval to make higher nicking, means you should increase the nicking percentage. Like if you have 100% nicking, means you are getting a good seed set. Okay, that's what you should remember. What is anther syncing interval, and how we can modify the anther syncing interval, and what are the factors affecting anther syncing interval, and what is nicking, and why it is important in hybrid breeding, you should know. Then when we go in detail about what is single cross hybrids, they are in nature, genetic constitution of the single cross hybrids, they are heterozygous in nature, and they are homogeneous in, when you take the population, they are one and the all the individuals are one and the others the same, and they are highly heterozygous in nature. This you should remember many times it asked. Then they having higher yield potential and very easy to introduction, because they are perfectly inbred parents are crossed, and the F1 you are going to get is highly uniform. If high uniform means you can standardize any mechanization so that we can easily harvest. That's why hybrids are more popular. This was the one reason, because of their higher uniformity, and we can apply a mechanization. Where the labor is limited in many advanced countries, there actually hybrids are very much popular. You can observe. Then, probability of identifying two parents having high passive performance and combining ability and nicking is highest. Means, for example, you have a double cross parents, double cross hybrids. Means you need to maintain 4 inbred lines. And having all the inbreds which having a similar nicking, so that we can cross and then we can maintain the hybrid. It's very difficult in other than single cross. Maintaining 2 inbreds are very easier, or maintaining 4 inbreds are very easy. In terms of passive performance, in terms of nicking, in terms of managing anther-syncing interval. That's why single cross hybrids are more easier to develop, and the performance and the uniformity is highest when compared to other conventional hybrids. Okay, then registration is very easy. Means you're having only 3 individuals: inbred 1, inbred 2, and F1. And registering only 3 is very much easier registering than 4 or 5, 6. Okay, in double cross, how many you are going to get? In double cross, you are going to get at least 7 populations. Okay, 4 inbreds. Okay, 2 single cross hybrids, 1 double cross hybrids. Okay, 7 lines you have to register. It's very difficult and tedious task. But in single cross hybrid, we're having only 2 parents and 1 F1, and registering them is very easy when compared to other conventional hybrids like double cross, three-way cross, modified group cross. Okay. Then here nicking is 1. Means you have to maintain only 1 nicking. Means inbred 1 and between inbred 1 and inbred 2. Only 1 nicking. And number of isolation is 3. Why? Means you have to maintain the inbred 1, we need isolation. Inbred 2, 1 isolation, and F1 had F1 plants you have to maintain, that is 1 isolation. Means for single cross hybrid we need 1 nicking and 3 isolations. Okay, understood this point? What is single cross hybrids? What is advantage? What is the genetic constitution? And what is the number of nickings we require? And what is the number of isolation we require? Understood, everyone?
Yes, sir.
Yeah. Then, what is double cross hybrids? It means that we discussed like inbred 1 and inbred 2 crossed F1, inbred 3 and inbred 4 was F1. Then you are crossing this F1 and you are developing another F. Means here we need 4, 5, 6, 7 isolation. Means you have to maintain the 7 populations. Then we need 3 nickings. 1 nicking here, 1 nicking here, and 1 nicking here. Means having a 3 nicking and 7 isolations, it's very difficult to maintain. That's why nowadays double cross hybrids are not that much popular as single cross hybrids. There is one question regularly asked in our comprehensive exam. Initially, there is a single cross hybrids were famous, then single cross hybrids were famous, then there is a downfall of single cross hybrids, then the rise of double cross hybrids uses, then again they are going to fall, then again single cross hybrids are much popular. Why this graph is so like this? There is always a comprehensive question. Okay, please interrupt this question, like you just analyze this question, why is it so, and tell me the answer in the next class. Okay. Then how to do hybrid seed production? First, have to cross female and male parent. Then you have to maintain them in a very good isolation distances. Like you have to maintain, because they are highly cross-pollinated in nature. Like normally we develop hybrids in cross-pollinated nature. We should maintain in some isolation. Okay, to avoid cross-contamination. Then you should maintain a planting ratio. This is always in ASRB. Definitely you note it down. There will be questions on all these things. Okay. All the points they have questions. There will be question on rogging. There will be question on planting ratios. There will be question on emasculation methods and different crossing methods. And what is forced pollination? What are the different types? What does it means? Then how to maintain them. There are aspect they're having a question. Okay, please remember what exactly these points are and what are the different planting ratios in different crops. Okay, what is the planting ratios in per millet? Means how many number of rice you take in rice. If you want to develop a rice hybrid, what's the planting ratios we required? 2:8. It's varies actually, depend on varieties, different on line you are using. Generally, you take you are using a 2 male line and 8 female line. Always remember female line should be more. Why?
The economic part is depends on female.
Yeah, because we are getting a seed set in a female, and pollen normally it produces very high. In nature, pollen production is very high. Okay. Then, if you collect all the pollen from the 2 lines, you can able to make pollination with the 8 other lines. Okay. It may be difference. If the pollen parent is big, you may increase for 3 also. It is nobody will going to stop you. But generally, it is 2:8. Okay. There are several ratios for each and every crop. At least you should buy hat. Okay. Planting ratios for each crops. Then rogging methods. Okay. Then what is rogging? What is rogging?
Removal of
Removal of
unwanted plants.
off types.
Off type
For
plants.
example, having an inbreds. You are maintaining an inbred block and F1 block. If there is an off types in the inbred blocks, then you are making crosses and they are developing a hybrid. The maintenance of hybrid will become very low. Like you may, that's why like many hybrids are nowadays only popular for some years. After that, they are going to lose their performance. It's mainly because of the maintenance of inbreds are very. That's why nowadays maintenance breeding is very required. Many people ask you for recruit you for maintenance breeding. Already so many like varieties are developed, so many hybrids are developed. To maintain them, it's a very difficult. That's why those who are expert in rogging means identifying the off-type plants, removing the off-type plants, and maintaining the purity of the particular population. It's a very tedious task. The definition seems to be very easy. In field, it's very tough actually. Then you should remember what is the definition of rogging and what is the importance in the breeding, maintenance of the lines and the varieties. Then what is emasculation methods? Because to have a successful hybrid, 2 things are must. One is the predominance of the dominance variants, and another thing is the ease of production of the seed. Ease of production of seeds. Okay. Ease of production of the seeds is very important. How the seed production will be easy?
If we use any genetic emasculation systems.
Genetic emasculation. Okay. In case of maize, which is the famous case
Detasseling.
of maize? Yeah, detasseling. Yeah. Because detasseling is very easy. Simply remove the tassel and you just bag the pollen parent. You just bag the female parent. Then you can easily maintain. Okay, rather than developing and introducing the male sterility systems and making them, it's very tedious, sir. Because when you have a more easier system than the male sterility system, people will use more easier system. That's why in maize, detasseling is very famous. It's not like that. It's not means that there is no male sterility systems in maize. There is a famous male sterility systems in maize. Can anybody recall what is the famous male sterility system
CGMS.
in maize?
CGMS.
PGMS, no, male sterile line.
Texas cytoplasm.
Texas CMS
T
T.
cytoplasm. Okay, T cytoplasm. Okay, you should read about what is the story, why it becomes susceptible to southern corn hybrids, how to recover, and everything you should read. Okay, they are very important for the exam. Then emasculation methods in each and every crop is very important, and what are the different crossing methods also very important. I'm not going to discuss in detail. Okay, then forced pollination. Sometimes we recurs. For example, we need, for example, in sunflower, we are going to apply a jaggery and a jaggery means to attract the bees, to attract the flies. When we are applying jaggery means we are applying improve the pollination. There are many methods. Either you can use bush, like if you're passing the threads on the rice fields, the pollination, forced pollination will takes place, and jerking the pearl millet, and each and every very important. Which forced pollination method in different crops is very very important for the exam point of view. Okay, then you harvest the seed. First you cross, then you maintain all of the parents, all of the F1, then optimum planting ratios you have to maintain for the successful seed production, seed setting, then roguing the off types, and the better use of, for example, in Chile, it's highly self, like the flower system is like that. It's very tedious to emasculate and do this one. If you have a male sterility system, it will become very easy. In rice, you can see. If you use normal hand emasculation method, it's very tedious task to make the crosses. If you use the cellular system, male sterility system in rice, it will be easier to develop the hybrid rice. Then, for example, you take cotton. There are a number of CGM systems are available, but nowadays mostly used technique is a dusting only. Okay, just take the pollen and dusting into this one. Okay, hand emasculation dusting is very famous method. Like which
Soda ash.
emasculation method is more famous in which crop? It's very important for the examinations. Okay, then for example, you take a maize, like, and many of the time I'm dealing the whole atrocious concept based on the case study of maize only. For example, you take the maize, the nicking, how the problems of nicking. For example, maize, God, I don't included the image. I could have included the image. Okay, there is a question like, for example, sometimes you can see in the field there will be seed only on the cob. There is a seed only on the cob. Okay, seed only on, sorry, so seed only on the top of the cob. Sometimes you having scattered seed means there is no proper rows, there is no proper this one. Sometimes there are seeds only on the lower half. You may not get seed setting on the upper half. Having seeds only on the lower half. Sometimes the poor tip filling. What is the reason? For everything there will be a reason. Okay. For every condition there is a particular reason. For example, you are getting seed only on the top of the cob. Why it may appear in you are crossing two parents in F1, in F1 curve, think this is F1 curve, you are getting seed setting only on the upper side of the curve. What might be the reason? Don't read this. I have given everything in the slide.
The synchronization time can vary, sir,
No,
between
no,
the
no.
silk and.
That vary. Why? See, you are getting only on the top,
Sir,
in some
that
condition only below.
acropetal basipetal nature, does it
Yeah,
plays a role, sir?
that plays a role. Okay. How? If you are getting, I'm asking question, seed setting only top of the crop, then what might be the condition? In what
Sir,
condition you may get only seeds on the top, not as full?
incomplete emergence.
Sir, if
That may be
the
the but
pollen
major
set is
reason.
late, sir, if the pollen set is late, that for that time, only the top portion of the cob is active, sir. Remaining portion is already matured, and the pollination won't be successful at that time
Why? Why is it so?
because the acropetal manner of the maturing of the pistils.
Exactly. Okay, I will discuss. For example, before we going to understand this phenomena, you should know the nature of the flowering. And I am telling you, every crop you are a breeding students, you should remember the nature of the flowering nature of the almost all very important crops. Okay, how the flowering biology is like takes place. It's very important in each and every crop. For example, you taking Uh, uh, for example, you are taking in maize, silk emerges from bottom to top. What is this nature called as?
Acropetal.
Acropetal. Acropetal succession. Then the pollen nature is the plural biology is basipetal in nature. Means from base, the flowering will start from tip and moves towards the base. It means basipetal. The tassel is basipetal in nature and cob is acropetal in nature. Sometimes you may get seeds only on the top of the cob. It may happen because of, for example, early silking. Means, as I already told, silk is emerges from bottom to top. Okay. Here it will start flowering. Here it will start flowering. Keep on going and last flowering will take place in the cob. But at the same time, your pollen parent is late. Means it will set the flowering at very late. Means the late pollen, by the time it reaches to the female, it lost its receptivity. It will going to lose its receptivity, sigma receptivity. So that the whatever the pollen is coming to reach the bottom, because it's matured very early, the receptivity will going to lose. You may not get any seed setting in the below of the cob. But as late pollen, we synchronize with the nature of top flowers of the cob, because it start from the base and move to top. Means the flowering also late here. Means late pollen will combine with late stigmas. But those who are already early stigmas, because of loss of sigma receptivity, you're not going to get the seed. Same vice versa in this condition. Pollen come early, but there is no production of female flowers at the tip. That's why you're not going to get any cob here. But you may get cobs like seeds on the cob at bottom. Okay, this may happen. Then sometimes what happens? Um, pollen shedding is like, as one girl said, like pollen emergence is very low. Okay, and due to high rain, your pollens are washed away in the rain. Because of high stress, there is sterility. That's why you are getting only few pollen will come and set the seeds. We get scattered seed on the cob. Then poor filling it based on emergence, as I said. There are so many factors. Okay, this is what you have to understand. This asked in 2022. Actually, this question was asked. So why it is so? Okay, remember this. Understood what is this? Either you read anywhere, it will available.
Understood.
Then, what are the desirable character we need in a female parent? Should be high yielding because the economic part, it bears the economic part like our seeds. It should be high. If it is low yield, you are getting low seeds. Then the cost of seeds will be very high if it is a low seed production. Then short plant height. For example, if female is very tall, the male is very short. The pollen has to climb. If male is very tall, female is very short. Pollen seeds like pollen reaching of the pollen to the female part is very easy in case here. Short female, tall male. But if you have a tall female and short male, it's very difficult to get the seeds. Understood why we need a very short height female plant in hybrid seed production?
Yes, sir.
Understood or not? Yeah.
Yes,
Then
sir.
and easy emasculation methods we have discussed. and it should tolerate to disease. For example, if disease susceptible, you will going to lose all the seeds and what will cross. Okay, that is the important characters. Then what is the characters we are desirable in the male? It should be taller than the female because of ease of reaching the pollen to the female. Then we should high product. It's not. It should not be shy pollen donor. It should be very um seed production like pollen production should be very high. Then it should have perfect nicking with the female. Means the pollen will synchronize with the flowering dates of the female. Then it's obviously should resistant to all the pest and diseases and biotic and abiotic stress. Then this is about the mesh, and whenever actually double haploids. Okay. Then another things I had to discuss history. History of your hybrid corn. Okay. Wait. Actually, all these now you understood what is hybrid technology, how to develop hybrids, what the desirable characters of female, what is the desirable character of males, what is the problems, nicking, silking intervals. Okay. Then we will see the what is the history of how the hybrid technology is developed. Actually, um, where is it? Yeah, where is the slide, sir? Yeah, actually, it started with W.J. Beale. He actually pointed detasseling technique in the hybrid seed production. Like he started like whenever there is, he just cut into the tassel and he just use the instead of allowing for a open pollination, he just making desirable crosses, and he developed some lines. By that way it started like this. Then in 1880s, then the later the scientists came like Shell and East. They have worked on in US like Cold Spring Harbor, and independently they have worked and independently developed this concept. One is inbreeding depression, the another is concept called as heterosis. And we discussed what is heterosis and what is genetics. Then the key important papers they have published is one is composition of field of maize in 1908, and another paper is called as pure line method in corn breeding in 1909. Another paper is called as hybridization method in corn breeding. Wait. Yeah. Actually, these three publication actually has revolutionized the hybrid breeding. Actually, when Shell started working on the maize, he's just simply working on Earlier in that 1901, which was the famous theory was pure line theory. Everyone behind the pure line theory and started developing the pure lines in every crop. Even Shell also tried the pure line method of breeding in maize. Then he started selfing the maize. Then surprisingly he got when started selfing the maize lines, the performance greatly reduced. Then he actually like yeast also actually yeast actually. Then he developed he developed the concept called as inbreeding depression. But he never attempted the crossing these low performance inbreds and getting hybrid. He never thought. Actually, Shell also worked the same. Actually, they have some conflict also. Actually, that is very in heterosis breeding book. I think it is mentioned the stories. Okay. Then Shell also having observed this phenomena, but Shell made another step. He just crossed the poor performing inbreds, and surprisingly, the F1 what he got, it become very robust and very vigorous. That's why he defined the definition of heterosis when the inbreds, the two different unlikeliness alleles, come together in F1. There will be increase in the resistance, increase in the vigor, increase in the size, then increase in the development happens when you cross a two unlikeliness, the inbreds having two unlike alleles. Then he firstly like he submitted a paper based on these results, hybridization method in the corn breeding. This is what very important. Shell and East actually independently how they have proposed the concept of heterosis and inbreeding depression. Remember the year, okay, and the title. Then why? What is the challenge? Okay, they have developed the concept, but what are the challenges? As I said, the poor vigor and yield of inbred parents. When they have developed inbreds, because of high inbreeding depression, those developed inbreds are poor performing. The inbreds are poor performing means then definitely the production of hybrid seed is very difficult and it's very costly because of limited seeds. That's why the hybrids are not that much popular. Even these crosses are there. Even the concept was developed, but they're not that much popular among the scientists, like among the foreigners. Then the later called the Jones, later scientist called as Donald F. Jones. He actually developed a double cross hybrids instead of single cross hybrids, double cross hybrids. And suddenly, double cross hybrids become very popular among the US farmers. Why? Why double cross are though so much popular than the single cross hybrids? Any reason for that? Anybody know that?
Sir, hybrids are more vigorous in case of seed set or viability, sir, than the
Exactly.
inbreds.
Yeah. Here you are using hybrids, uniform hybrids as male and female parents. Here female parent is hybrid so that you are getting more seeds, more crops like then then definitely higher production in the double cross hybrids. But later it also lost its popularity. Again, single cross hybrids are become very important. Why is it so? It because earlier there is no that much a good technologies to develop inbreds by overcoming the effect of inbreeding depression. Due to continuous breeding efforts, we can minimize the inbreeding depression and we can develop an inbred with a superior performance so that the superior inbreds can be used as the parents in the hybrid seed production. That's why first initially single cross hybrid developed, it became popular, but suddenly it fallen down. Then double cross became more popular. Then due to maintenance of double cross hybrids is very difficult. Then again its popularity get reduced due to development of superior inbreds. Then again single cross hybrid technology get popular. This is what you have to remember. Then the famous books published by different scientists. One book is called as Inbreeding and Outbreeding in 1919 by E.M. East and E.F. Jones. And first Lemang inbred was developed by E.M. East. And first copper cross, the hybrid name copper cross, developed by Henry Hay Wallace. And it is the first hybrid actually sold very commercially in the US, and he became the vice president of America, actually United States of America. Then D.F. Jones in 1980 has discovered double cross hybrids. It is also very popular among paired. Okay. Then what is the impact of double cross
Sir,
hybrid? Hello?
sir,
Yeah.
that Burleving Dent also first commercial hybrid you told. This copper cross also first
No,
commercial
it is
hybrid.
first cross, but it is first sold. First hybrid sold commercially.
Okay, sir.
Even though that hybrid developed, but it's not that much popular. Okay. When Henry
Sir,
Wallace actually started seed production, like seed production company, it became popular. Okay. What is the impact of double cross? Means increase in the yield and reduce disease and pest problems and uniform plant flowering and plant structure, but it's not comparable to single cross hybrid. When compared to other open pollinated varieties at that time, it having uniform flower. But when compared to single cross, it is not that much uniform. Okay, you should always remember. Then rapid farmer adoption at that time. Then again it shift to single cross hybrid because of the development of more vigorous and more adaptable inbred lines. Again, lets the popularity of single cross hybrids. Means the yield was here increased by 1 barrel per acre or per year. Here 1.7 per barrel per acre on a year on an average. Okay, this is what how a single small technology can revolutionize the cropping systems, especially in the maize. Then again, there is development of heterotic groups. Then what is heterotic grouping? We are going to discuss in separate class. Okay. What is heterotic grouping? Anybody have an idea? Tomorrow I think I will discuss that. And tomorrow,
sir,
after heterotic grouping, I will discuss biometrics.
inbreds showing better combining ability are separated into separate classes, sir.
Yeah, that we will discuss. Okay. There is a proper definition. Okay. There's two populations. You have to make the inbred lines into two populations. Whenever it crosses, it should perform a better. It should produce better heterotic hybrids. Okay. Then there are many ways to make that grouping. That is we can discuss single cross method, top cross method, GCM method. There are a number of methods, but not that much required for SRP. These things you are going to read in future PhD. Okay. That things I will not go in detail. Just I will discuss what is the definition, what is the heterotic group history, and the types. Then after that, actually, I thought to discuss the biometrics of heterosis. After learning a quantity genetics, you are going to learn. You should know what is the average effect of gene. You should know what is population mean, and you should know what is genetic value. Then only we can able to understand what exactly the H is equal to dy square. Okay. Okay. Today's
Sir?
this much for today's class.
Sir?
Yeah. Ask us.
Sir, how exactly they will reduce the inbreeding depression, sir? While
Yeah, that was the skills of the breeder actually. The prop continuous selections. Okay. While when they have continuous selfing, then definitely they had to handle at least 6 to 7 generation of population. There is a development of quantitative genetics, and there is a techniques came to like mating designs techniques were developed simultaneously, and the concept of variances, genetic variances, and to how to and the Fisher actually contributed more, like how to remove environmental variance and how to estimate the genetic variances. See, in 19 not only all these things are developed, and people started integrating all them together, and the selection power is going to increase. The skill of the breeder will going to increase so that he can select the better inbreds, so that high superior, high vigorous, and high adaptive. Okay, based on application of quantitative genetics, based on application of the skills, the improvement in the selection procedures. Okay, there are at the same time experimental designs also developed, so that while selecting they carefully chosen the plant and they are developed with better inbreds. Okay, those plants
okay,
showing a minimum inbreeding depression, they are selecting them. Okay, this is the
okay,
only reason. It's not like that any other reasons were there. Okay, okay, bye. Good night, everyone.
good night.
Thank you.
Good night, sir. Thank you.
And those who are regarding listening, recording lectures in future. Please attend live classes so that see the people are see only 5 to 6 people are there, and they are asking at least what are the things coming into mind. They are asking and they are answering. But if you're not coming to class and taking the, it's very difficult to manage, difficult to learn also. Okay, bye, good night.